Well, hello, everybody. Good morning, good afternoon, good evening, good night to everyone, wherever you may be across our lovely world. Thanks for joining us live here today for the one and only Serverless Office Hours. We are streaming on the AWS Twitch channel, so welcome if you're joining us from there, and also on YouTube via the AWS Events channel. So if you're joining us from there, thank you very much. We love to find out where you're from. We've got a massively global serverless audience. We're going to be talking about exciting things today. I'm Julian. I'm a developer advocate here at AWS, and super happy to be joined by the one and only James Wood. James, welcome to Serverless Office Hours. For people who don't know James, how on earth are you doing what you do today?
Good to be here, man. It's I think this is my first one. Is this the first time I've been on?
Maybe
Maybe like right when I joined AWS, maybe I did another one, but yeah, great to be here. Yeah, this is gonna be fun. So I've been doing a lot of AI stuff with Java and Kotlin lately, so that's what we're gonna dive into today.
So yeah, I mean, you've had a big, long history with Java over many kind of years. I mean, everybody says, I mean, Java's old technology, but Java's running the world at the moment. So yeah, I mean,
Yeah.
for people who've joined this, we are talking about AI and we're going to be talking about Java. But yeah, for people joining this, you know, what's the Java story in our sort of modern IT infrastructure framework when, you know, there are a million new runtimes, a million new JavaScript frameworks, a million new, you know, Rust, Go, all the kind of things, a million new different types of Java. So yeah, how does this all put together?
Yeah, good question. Yeah, I think kind of the big picture for me is I've been doing Java for almost 30 years. Yeah, so I started in 97 doing Java, and I've taken some detours, like did some Scala, which was still on the JVM, and then did some Kotlin, also on the JVM, and now I do like all the things, like, you know, Java, Kotlin, Scala, but also like dive into Rust and Python and TypeScript and kind of whatever. But the place where I see Java really fitting into this kind of next generation world of AI is that we built a lot of business systems with Java. So many things, as you said, like run the world in Java, whether it's financial services stuff or so many back office applications, so many SaaS products, like they're built on Java. And people kind of look at Java, they're like, oh, it's like the new COBOL or whatever. It actually has like evolved pretty significantly over the years. There's actually a new website that just came out just today. I think it's called Java Evolved. Here, oh, and let's put my screen on and I'll show you this. This is kind of cool. So my friend Bruno just published this site, and this is fun because it kind of captures like, okay, when you wrote Java like 10 years ago, you probably wrote like this, but now you just write this. And so he goes through on here with 90 different examples of like the old way and the new way. And I love that it's like showing like things haven't stood still with the Java language. Like things have gotten better. We've got pattern matching. We've got a lot of great stuff here. And yeah, records are great. So all sorts of good stuff. Fun website there, the Java Evolved website. So so Java hasn't stood still. You know, we still it's evolving well. A lot of stuff is built on Java, but then what about the AI side of things? So most people that have, you know, been in AI stuff for a little while probably have done Python, maybe TypeScript, maybe whatever. But Java is, I think, a little late to the show on being able to build AI stuff in Java. It was just about a year ago when I started getting into Java and Kotlin AI stuff. And at that point, there weren't even, other than the LangChain for J framework, there weren't a lot of things out there yet. And then Spring AI, which we'll talk about, kind of came on the scene. And that the release of the 1.0 of that was back in April last year. So all this stuff is like super new, but with, you know, many people getting into AI, building agents, whatever, I just saw this yesterday. There was a report that company Azul did, and they did a study with enterprises, and they found 62% of enterprises now use Java to power their AI apps. So that was great to see. Like you know, pretty quickly the Java ecosystem has started using Java to build their AI stuff and not having to switch languages. And then there was another one that came out a few days ago, which was a benchmark of MCP servers, and it compared Java, Go, Node, and Python. And this one was interesting because it said, all right, here's some key findings. The latency of Java and Go was like sub-millisecond, and in contrast with Node and Python, the latencies were 10 to 30 times higher.
Wow.
So, I think a lot of this stuff just points out like Java is this amazing production system that has evolved. The language has gotten all these new features, and so it's not the COBOL that people may think it is. It really is a great option for how we build our AI systems. So I don't know. What in your world, Julian? What do you see for Java? Do you encounter much? What's your take on?
Well, I see a lot of Java, and I've worked for enterprises for many years when Java was huge. And it's an interesting thing to see because some people, because our Java is so old, think it must be an old language. But the interesting thing is with something that is an old language, performance and optimization and everything has been, running for decades. And so, yeah, it's interesting to think of, all the work that's gone into that over so many years. The JVM is amazing because once it's up and running, it is super ridiculously fast. And then also in the serverless world, being a Java shrinking down to really be small, efficient, GraalVM, Micronaut, all those kind of things. So yeah, it's an interesting story. I like the things that are old, that get continually updated, and people may think they're boring, but they run our lives. Why not?
Yeah, sometimes the boring tech that is the most useful, stable, reliable. And one interesting side note on the serverless side of things. So a lot of people, and even this article, when it talks about Java, it says, yeah, there's some startup, some additional latency when you start up your Java application, and then it uses quite a bit of RAM. And that's often in the serverless world the thing that people complain about with Java is that overhead of the JVM. But there's an alternative that not many people actually know about outside of the Java community. It's called GraalVM. And this was an amazing technology that Oracle created that will take a JVM-based application, so this could be written in Java, Kotlin, Scala, whatever, and it actually ahead of time compiles it down into a native binary. And so it actually then uses much less RAM and starts up in sub-millisecond. And so so many of the Java frameworks that are out there and other things in the Java ecosystem now support GraalVM. So now you don't have to worry about that like cold start when you do the native compilation. And one of the things that I like about the GraalVM approach here is that when I'm working on an application that I may run in production on GraalVM with that super lightweight binary, when I'm working locally on my machine, I'm still using the JVM, and the reason for that is that I want that like super fast, like just swap out some classes and reload the thing, as quick as I can. I want the super fast cycle time when I'm doing local development, and of course that also helps when I'm having an AI agent, help me write code. And so then when I'm ready to like actually get to production, that's when I go through the native compilation process, and then I can run that native binary, on Lambda or wherever. So so there is an alternative to running on the JVM that can take the same application and reduce a lot of that overhead. You do lose some things with that. So one of the nice things about the JVM and the JIT is that it's constantly improving the performance of a running application, but that requires that the application runs for a long time. And so when you do ahead of time compilation, you can give it like profiling information and get some of those kind of benefits of the long running optimization ahead of time, but you may not get as many optimizations as you would get with that JVM that's constantly like watching for things that it can optimize.
But I love that the Java community has also taken on this sort of serverless approach, with GraalVM, and that's from Oracle as well. Not even a third party thing, and doing this whole AOT thing, and I think that's amazing. I think the less memory, compiled to native binary is super powerful, but having that local developing experience that you don't have to worry about that, it's only something you really care about at compile time. And then obviously, when talking Lambda and we've got our own things with, provision concurrency or snap start or all those kind of things. So I suppose the meta comment is, anyone out there thinking Java on serverless specifically, never mind just the AI, oh no, that's slow and clunky. You've got many options nowadays. And I mean, we have, internally at AWS and across Amazon, and many customers who are, doing, massive
Java,
things with Java.
Yeah, totally. Yeah, so lots of great options there. And yeah, Snapstart, I'm glad you mentioned that, because also a way to reduce that Lambda startup cost. So yeah, and I think there's a couple other options as well, with like being able to better cache the class files that get loaded and some of those things. So
yeah, interestingly, Spring being such an important Java framework. I mean, old sort of old things to think about was like, having these sort of big frameworks running in Lambda specifically. That's not necessarily the great idea, but I think with all these other kind of things, that advice is no longer up to date.
Yeah, I think early days of serverless, it was like, oh, don't use frameworks because they're too heavy, they're gonna impact your cold start, all that kind of stuff. But now it's like, no, just use Spring or use Quarkus or use Micronaut. There's lots of great options that you can do all these then optimizations to avoid the overhead of that we used to have to think about and worry about. So on to Spring. So Spring is by far the most used framework in the Java space. One of the interesting things about the world of the Java ecosystem is that most people that do anything real with Java are using some kind of framework. And part of this is that we need some abstractions to deal with the massive complexity usually where Java lives. If you're building something tiny, then maybe you don't need those abstractions. But these abstractions allow us to work in large teams, allow us to have reusability, allow us to have all the different kind of cross-weaving concerns kind of built in. So things like observability, all that kind of stuff. And so most people in the Java ecosystem are using a framework, and Spring is by far the one that gets used the most. There are other options out there, but yeah, Spring is kind of the biggest used one. And so I mentioned Spring AI earlier, and want to go into a little bit of that, and we'll go into some code here in a minute. But Spring AI is one of the components of Spring that adds like all the typical AI pieces that you need when you're building an AI application. And so this is just looking at their docs here. We can see that, of course, they support chat client to be able to call a model. They support all sorts of different models, chat models, embedding models, image models, audio models, blah, tool calling, MCP, and RAG, vector databases with RAG, observability. So, this is like a pretty amazing suite of things that cover really all the AI use cases that you may want. Interesting side note on MCP, which we'll get into in a little bit, but the Spring AI team is the primary maintainers of the Java SDK for MCP, and so then they wrap that into a nice Spring module, which we'll look at in a little bit. And so at AWS, we work with the Spring AI folks, we work with them on MCP and on Spring AI things. And so we're constantly adding new support for like Bedrock, just added like prompt caching, so we worked with them. I don't remember if we contributed that but there has been contributions like that where we work to make sure all the AWS stuff works well in Spring AI. So I'm going to go into some stuff on Spring AI, but Julian, any
I think and I'm gathering that I'm a bit frozen on the stream, so I don't know why. I'll refresh my browser tab, which may kick me off for a bit, but we are probably live. We are live streaming, as you can see. There are some questions and comments which will come in. I'll get to them as soon as I can add them in. But just to know that, it's good to know that Spring is not just one or two little things bolted together. This is a whole sort of platform.
Oh yeah, whole platform for AI. Yeah, exactly. Okay, reload and then come back and we'll do some questions. And while you're reloading, I'll talk about another framework real quick in the same ecosystem.
Awesome. Carry on.
Yeah. So there's Spring AI, and that's great for anyone using Spring. There's a number of other options for AI stuff in the world of Java and Kotlin. One of the ones that I think is really interesting is called Mbabel. Mbabel is created by Rod Johnson, who was the creator of Spring, and so he doesn't work on Spring directly anymore, but he created this new agent framework called Mbabel, and Mbabel is I've done a bunch with it, and Rod has an amazing series of blog posts. But the thing that I love about Rod is that a lot of the agent frameworks kind of like do basically the same thing and address things like RAG and tool calling and that kind of stuff, like all kind of in the same way. And what Rod has done differently is he's gone to research and like academic research papers and tried to find like what is the best way to tackle this particular problem. So as an example, he wanted to bring higher reliability to agentic workflows. And one of the challenges with that is that they can be pretty non-deterministic in how the agent like figures out a workflow. And so Rod thought about this, and he discovered through academic papers that in the world of gaming, there's something called GOAP, goal-oriented action planning. And GOAP is a deterministic way to plan workflow. And so in Mbabel, he actually uses GOAP as the way to plan a workflow, and he uses the type system. So types describe the kind of inputs and outputs to parts of a workflow, and then GOAP deterministically defines what the workflow through those are. And so that's just one example where Mbabel kind of takes a very different approach than other agent frameworks. And this is actually built on top of Spring AI, but creates these nice higher level abstractions like the GOAP planner and all sorts of stuff. So I won't go too much into Mbabel today, but just love that there's some real real kind of forward-thinking and interesting pieces around how we do agentic systems, and this is all on the JVM.
Okay, cool. I'm back. I can't move my head. I think I'm back. Yeah, from the beginning, Daryl Ruggles, who is a good friend of Serverless Office Hours and joins us regularly, was when we're talking about the history of Java. I learned Java in 1999. Also, we're thinking in Java. Hard to believe it's still going strong. Absolutely, and of course, very strong in enterprises. Much of the code we're developing today is still Java. Well, good to know, Daryl.
We had quick on that note. Yeah. So, thinking in Java, that was my first Java book. That's how I learned Java. I was writing Java in a very non-object oriented way. I was writing it like I wrote my Perl, and then I read Thinking in Java by Bruce Eckel, and totally like taught me object oriented programming, and that's when I like really kind of dove deeper into Java. And fun side note, I have a podcast with Bruce Eckel called Happy Path Programming, and so we don't do it super often, but we do get together and talk about all the world of programming things, and so that's been super fun. We both live in the same mountain town in Colorado, and we just about a year ago finished a book together with another guy named Bill Frazier called Effect Oriented Programming, and we're working on a second kind of edition of that'll be based in TypeScript. So anyways, I love that Daryl mentioned Thinking in Java.
Oh wow, fantastic.
Because got some fun connections there.
Yeah, I think I may have even bought that book, and I never really got hugely into Java. I didn't, I wasn't a big developer at that stage. I'd done development before them in old languages like, I don't know, Turbo Pascal and DBase and Clipper and all those kind of things. I'm sure, was it a sort of brownie cover? I suppose in different editions. I seem to remember sort of brownie cover with, I don't know. Here, I must have a look. In fact, I must look at I'll look up on my Amazon purchases from the year 2000 and see the Java book. Nice. Java book is there. Yeah, and then Reginaldo, that's a good one. AOT is pretty neat tech, absolutely. And then you carried on to ask, how do we run the native result from GraalVM inside AWS Lambda? Does it need to be a container? No, it doesn't need to be a container. It is just a binary. So it can ultimately be run as a custom runtime, and there's lots of documentation stuff out there to be able to do that. So yeah, certainly doesn't need to be a container unless it needs to be more than 256 meg, and then you may as well use a container. And I would also say that using a container isn't necessarily a scary thing. It's actually pretty simple once you wrap your head around doing it. And then you did ask, I'm using Quarkus with Lambda handler, works nicely with Snapstart, but I wonder if it'll work better with native build. I don't know. Give it a try.
Yeah, let us know. Question for you, Julian, on
Yeah.
the native image stuff. So when I've done stuff like on Kubernetes and other platforms, and I've created my native images, one of the things that I do is I get kind of crazy on the optimization of my container side of things. And I have my native binary be a fully statically linked native binary, so that I don't actually need an operating system in my container. And so all that essentially all that's in my container is just the binary. And GraalVM can create these binaries that you can do a from scratch container. Would there be any benefit on Lambda to doing a from scratch container, or is that not even an option? Do you know?
Yeah, that is interesting. I did not know, because there are obviously parts of a Java application for Lambda that need to talk back to the Lambda service, and that's called the Lambda runtime interface client.
Yeah.
But yeah, I didn't actually even realize that was an option, that you sort of didn't need an operating. Well, I suppose you need Amazon Linux or Ubuntu or something underneath the hood, as a base operating system, and then run a binary on top of that. But how much of an actual runtime you need underneath that? Yeah, possibly.
We'll
Interesting.
have to explore that together.
Yeah, I didn't know.
Yeah,
that
it's so you, on other places like Kubernetes, you can run these from scratch containers which have no operating system in them. And I don't know how that actually works.
Yeah.
Something in the virtualization layer can manage all that. But yeah, it's kind of fun to I have one production application where the container image is in my case, a Scala application, and the whole container image is, I think, 8 or 12 megabytes for the whole thing. And I just love
crazy.
that. It's awesome.
And it's a JVM based
and it's a JVM based application, that I built with GraalVM native image into the static binary. Yeah.
Wow,
Yeah,
excellent. Punchard, thanks for joining us via YouTube as well. I always tend to go for ECR instead of Lambda, and ECR works well. Is the reason why I choose Lambda over ECR. I presume you're meaning ECS, not to be pedantic. ECR is the container registry. Is there a reason to choose Lambda over ECS? Two different things. I think Lambda comes with a automatic patching. So Lambda under the runtime just patches your Java, your Python, your Node, your whatever under the hood, and it's really good for spiky workloads. So if you don't know, for Lambda you pay per millisecond for every request that comes in, and you pay that, and so you literally pay per millisecond for what you use. ECS is slightly different, where you pay for what you provision. So yeah, it's actually really simple to set up a Docker container and off you go, run your application. But you do need to then patch and manage that. You've got to stick a load balance in front of it. You've got to manage and have some ingress. So you've got some service that is running then on your ECS container to handle that HTTP endpoint or whatever endpoint coming in and sending it back out. Lambda is just a little different. It uses an event-based model. It's called the handler, so something slightly different from HTTP. So yeah, different options. I would say if you're using ECS, great, but go for the Fargate option, because that means you don't have to worry about EC2 instances. And so, yeah.
Question on that for you. So I was actually just looking into this, and I didn't get a good answer in my brief searches, but can ECS actually scale to 0 for like a web workload?
So ECS can scale tasks to 0, but for a web workload, that wouldn't be a great idea, because the spin up time, so something would have to start that task up, and then the spin up time would be a minute or two.
Really? Okay. So that's, I guess, a big difference between Lambda is.
Yes. So the spiky workloads kind of thing is also from the start perspective, that Lambda is basically always ready to go. So where ECS does scale down to 0 is when you have asynchronous tasks or things like that. So you need to do, I don't know, some image rendering or something. You want to spin up a container to do that, or do some batch processing, ETL kind of thing. You can definitely, hook it up to EventBridge or step functions, or even manually. And when that task definition spins up, it takes a minute or two, but it doesn't matter, because, ultimately you've got a big beefy box doing some data processing or something like that. So yeah, Lambda is always running. Lambda can scale up to 1,000 requests immediately without you having to do anything. So that's pretty cool, and can also add another 1,000 requests every 10 seconds. It's sort of called concurrency. It's slightly different thing. The nuance may be a bit more complicated for that. But yeah, ultimately, the fastest way to get scaling in the cloud is to use something like Lambda, because you can just have a website running in your Lambda function, or anything running in your Lambda function, point to it, and the scale will be completely down to 0 if nothing's using it, and then scale up pretty quickly. And yeah, 1,000 concurrent requests every 10 seconds adds up really quickly. So you can, yeah, if you think an application, even if your web request is, say, 100 milliseconds, so that's 10 of those a second. So you've basically got 10,000 requests per second that you can ramp up to. So give it 100 seconds, and you could have you can have 100,000 transactions per second. That's a pretty big website, and you've started from nothing, and you didn't need to pre-provision anything or do anything. So, yeah.
Awesome. Cool. Any other questions before we go on?
Yeah. Well, Reginald said from scratch image. Wow, that is so cool. I'm going to research. Please do, and let us know.
Yeah, and I need to do some research on that side as well to see if it's supported on Lambda and if there's any benefit to doing it from scratch container. Yeah.
I'm sure it will probably save you money if it's only that few meg in memory. Lambda, you're going to charge by memory. Normally, a Java app, you're thinking, at least 512, maybe a gig of RAM. If your binary is much less, maybe you can save a chunk of money.
Yeah, that's true. Nice. Okay, so moving on, I want to show some code. Should we dive into some code for some of this?
Always
stuff?
Good. Always
Great.
Good.
Okay, so let's start with let's see, the first one I want to show is just our very basic like hello world with Spring AI, and this one's going to be like an AI agent. We're going to be able to do a chat client. So let me walk through this, and then we'll see if we can get it up and running here. So first thing is that we need to configure. Oh, this is the wrong project. Hang on, not that one. Not that one. This one. Here we go. So first thing we need to do in this project is configure how we're going to talk to a AI model. And there's a bunch of different options that we can use in Spring AI for different models, different model providers. But one of the cool ones that I like here is that there's a library in Spring AI, which is the OpenAI SDK. So I just brought in that dependency for this OpenAI SDK model. And then what we can do is configure what we want to connect to for the OpenAI SDK to connect to. And AWS now supports, through some of their models, a endpoint which is compatible with the OpenAI SDK. It's called Mantle, and so I point the OpenAI SDK to the Mantle URL, and then I'm also using the AWS bearer token here, which is an easy way, especially for local dev, to just give it a token. I don't have to set up any other auth stuff. I could just go into the console, create a bearer token, so that is an environment variable. Done, and then we can give it the model that we want to use. In this case, I'm using the OpenAI GPT OSS 120 billion parameter model. Okay, so that was my configuration for the model side. Julian, all that making sense so far?
Yeah, no, that's good. Because obviously there are different ways of Bedrock. You can connect via Bedrock native. What is the advantage of then using OpenAI via Bedrock but via Mantle?
Yeah, good question. So Spring AI does have the Bedrock Converse one, and I'll show that one later. And so I like, in terms of like what's better, what's different, I think there's some price difference and throttling differences between the Mantle models. Like the Mantle models are generally, I think, less expensive and have higher limits because this is kind of a next generation model inference infrastructure in Bedrock. So I think that's one advantage of using the Mantle models through OpenAI SDK, and then other ones is just like it's kind of, I think it's kind of nice to have. I think the OpenAI SDK is actually a pretty good Java SDK, and so using that to do all of our model stuff, I think, is good. But really, up to you. You can use the Converse, you can use the OpenAI SDK, or you could just talk to the stuff directly through the AWS SDK as well if you wanted to.
Yeah, that makes sense. Yeah. Just some context. The term Mantle. We actually, if you look at some of the keynote stuff and talks at reInvent last year, Mantle is our new sort of inference engine for Bedrock. So And I know one of the principal engineers working on it. And it's an actually fascinating project where previously every single model used to, you can imagine it, it's running on EC2 instances connected to GPUs, and you've got a load balancer in the front of it. And we basically have to manage, which EC2 instance you're going to go to with these GPUs. But you can imagine, I don't even know how many models are running on Bedrock at the moment, but it is a lot.
It's like
and
250 or something at this point.
Yeah. And previously there used to be different pools or different auto-scaling groups and different load balancers per model. And that was great because you could sort of corral your models and you knew exactly what it was running on. And in a big region, that would be great. But in a small region, there's just vast amounts of sort of waste in the system. And the thing is to then bring up a whole EC2 instance, load a model, and then put it behind a load balancer takes some time. So the whole Mantle thing is actually to flatten all of that inference. And they basically got far bigger sort of hot swapping of the models, where behind a single load balancer, they can take one particular model out of a GPU and load another model into the GPU far more flexibly. And the benefit for you using it means you're not going to have, there's no capacity. Because previously, there may have been huge capacity in the actual Bedrock fleet. But for this particular model, lots of people happen to be using it, but there could be 100 other models underutilized. And so, going forward, there's this whole big way of doing inference at scale across multiple providers, multiple models, and should be a lot more flexible, and should mean the average utilization or average capacity available to people would be much higher. So I thought that was nerdy and deep dive in cool.
Cool.
So
yeah, nice. Okay, so that's our configuration side, and then let's look at our little application here. So this is my Spring Boot application, and I need to build a chat client to be able to talk to the model. To do that, I inject. So one of the core parts of Spring is dependency injection. So I inject the builder in here, and then I need to just build an instance of our chat client. And this just allows us the opportunity to specify some additional configuration at startup time for this chat client, which I'll show in a little bit. And then for this application, I'm doing just a little web application. So I've got an HTTP router, and then I'm going to handle GET request to slash. And when we make a GET request to slash, I'm going to call the chat client. I'm going to send a prompt. I'm going to send a user prompt, and I'm just telling the model to say something. I'm telling it to make that call to the chat client, to the LLM, and then I'm getting the response with that .content. And then I just put that response into the response body. Oh, and this is Kotlin code, not Java code. The Java code looks almost exactly the same. There's not a whole lot of difference. So you can choose Kotlin or Java. And yeah, I'll show some Java in a little bit. But so that's it. Like, that's our entire application for our AI agent, the start of our AI agent. But let's run this thing and so we can see what this actually looks like. And Julian, any questions so far on our little AI agent here?
No, we're good. Excited to see.
Okay, so now let's go over here and let's pull up make a GET request to localhost 8080. So there we go, made the request. And one of the other nice things about Mantle is that it feels really fast. I don't know if it actually is technically faster on the inference side, but
can we just zoom in quickly just to see what it was saying?
Yeah. Oh yeah. Let's see. Here we go. So okay, so my prompt was just say something. That's why not very interesting. And so this time I said, sure thing. How can I assist you today? And the one funny thing about the OpenAI models is it uses a lot of emojis for some reason.
Yeah.
But here, let's hit reload, and then we'll get another one. Yeah. So that's it. That's like our basic Spring AI application talking to Bedrock there, exposed as a HTTP endpoint. So super easy, straightforward to start building these AI systems with Spring AI. There's some dependencies here, like we have our BOM, which is a way to have consistent versions of all our dependencies for Spring AI. We've got the AI SDK. I brought in actuator here, which is for observability, but I'm not actually, maybe we can show the observability piece. So it's super easy to add observability into into Spring AI. So that's a nice thing. And then I've got my web server, and then I'll use this MCP client here in a few minutes. But yeah, so that's like it. That's my build. That's my code, my configuration. Pretty straightforward. Okay, should I move on? Any questions?
No, we're good. We're good.
Okay. Cool. Okay, so then the next piece I wanted to show is around MCP. And so I'm going to switch over to another project here. And so I've got my Spring AI MCP server. And this one, first, let's look at the dependencies here. So again, I use my Spring AI BOM, and then I've got an MCP server. And then I added DevTools in here, so I get like auto reload and stuff. But that's kind of all I needed for my dependencies. Let's look at our configuration. For configuration, I'm setting a different server port 8000. That's so I don't get a port conflict there. But then I'm also telling it which protocol to use for MCP. So in MCP, you can do it over standard IO, which is a lot of the AI code assistant kind of MCP servers that are out there. You spin up on your machine, and then you connect over standard IO, fork a process, connect over standard IO to that process. And that's great for your local machine. But a lot of what I do with MCP and a lot of what our customers do is they have these MCP servers, which are essentially like integrations to their business logic, business data, and then they connect their own custom agents that are, they're running on AWS or wherever to those MCP servers. So more of like an enterprise data integration kind of pattern. So using MCP in that way. And so in that case, you probably want your MCP server to be running remotely over HTTP. And so there's a few different protocol options for MCP servers over HTTP. And then there's a variant in the kind of new transport protocol over HTTP where you can tell it to be stateless. And so that's the protocol that I'm using here. Streamable is the other option, and streamable is more of a stateful protocol. And in the stateful protocol, you can do some additional things that you can't do when you're stateless. But then you may not be able to scale horizontally as easily as you can when something's stateless. So some trade-offs on the protocol side, I think, for MCP. Then let's look at our MCP server. So again, I got a Spring Boot application, and in this case, I'm just exposing a tool. In MCP, there's tools, there's prompts, there's resources, there's all sorts of other things that you can do in MCP. But in this one, all I have is an MCP tool that adds two numbers together, and it's a very basic hello world there, and that's it for my application. Any questions so far before I start this thing up and try it out?
No, it seems so. I mean, I think even people who are not into Java can look at this and see the MCP config is very similar. You create a tool, give it a name and description, and I think that's one of the superpowers of MCP is the name and the description is a self-describing utility.
Yep. Yeah, exactly. So that description is really important because that's how the AI is going to know when it should actually invoke this tool. So yeah, thanks for pointing that out. So let's start up this thing and we'll see if this thing all works. So there we go. We got our server running on port 8000. So the first way I'm going to show this MCP server is over in Kiro. And so in Kiro, what you can do is connect to remote MCP servers. So I've put into my MCP config, which you just go to the little ghost here, and then you've got your MCP servers, and then you can click edit, and it pulls up your JSON. And then I've popped in here this remote MCP server, which in this case is running on localhost, but certainly could be running on AWS. And so that's the URL there. And then I think I do need to say reconnect because I restarted my server. So let's reconnect. So now I should be connected. We'll see that it sees that I have one tool here, which is called add. And so now if we go over in the chat and I say add 6 and 7, then what Kiro should do is it should be able to look at the list of tools that are exposed. And it says, oh, I've got a tool for that. So the LLM says, okay, I've got a tool that knows how to do adds, addition. And we'll see now that Kiro has recognized that it wants to call that tool. It's asking asking me to validate that I'm okay with running that tool with those parameters. And so I'll hit accept. And when I hit accept, then it makes the tool call, which if we go look back here, we should see the log, which came from that system out println. And so now we back into Kiro, we'll see that, yay, we got the response back from the tool call, and then the LLM, decided to say the result is 13. So great. So my MCP server all works, and that's exciting. So that's, pretty easy to get MCP stuff built and up and running with Java. Oh, and this one was Java, not Kotlin. So
So when you are thinking about hosting MCP servers, obviously we work for AWS, it's great to host them on AWS. What are the sort of options and sort of easy on-ramps that people want to play with this in terms of actually getting that MCP server running on AWS?
Good question. We're going to go into that. I want to show one other thing, and then we'll talk about it. So hang on, and we'll talk about AgentCore in a few minutes. But okay, so I've got my MCP server working. I did want to show how I then integrate that into the agent side of things. And so to go back to our little agent that we started with here, I'm going to now add into this thing MCP support into our agent. And so what I need to do is tell it, and I'm going to do it through config here. I'm going to tell it that I'm going to connect to localhost port 8000 to an MCP server. And then we're going to go make just a few modifications to our code here. So the first thing that I need is, an AI just gave it to me. I didn't even have to type anything.
It knows you well.
Thank you. It knows. Okay, so now in our chat client, I'm going to add a default tool callbacks, and I'm going to specify that thing that I just injected in. So this is just a way to configure my chat client to have the tools from the MCP server that it's connected to here. Okay, so that's all that I needed to do here. And now let's update our prompt to add 6 and 7. All right. Okay, so now I'm going to save that. I think that's all I need to do. Let's go restart my server. I don't think I had dev tools on this. I could have had dev tools and then it would auto restart. That's kind of fun, but I don't think I added it on this one. Okay, so my server, my agent is up and running again. And now let's go back here, localhost 8080, and hit reload. And if everything works, 13. Yay. So interesting that the OpenAI model just gave me just 13. It didn't say anything. It's just like here's your result.
Here's your answer.
Yeah. Whereas Kiro was like, the result is 13. Anyway, so, and then we should be able to validate that actually called my MCP server because we see there the login. So sure enough, the AI, had the list of tools, had the MCP server connected to it, knew that it had an add tool, it knew that the description, add 2 numbers, it knew what the input parameters were, and so the LLM was able to decide based on the prompt that I gave it to call the MCP server, and then get the response, send it back to the LLM, and then send it back. So all that worked great. Super easy to add that MCP functionality into our chat client within Spring AI. Okay, any questions on that before we go into deployment stuff?
We're sort of talking about the deployments, how to add auth in the MCP so we can deploy secure MCPs to AWS. I think we're going to cover that later, but that was
there's 2 things to mention on that. So we will talk about that a little bit on the AgentCore side of things, but Spring AI and the MCP support in Spring AI does have the ability to use something called Spring Security, which is another module within the Spring ecosystem, and so you can actually protect your MCP servers with Spring Security. So that's one way to be able to have authentication for your MCP servers. And quick little side demo here. I didn't prepare for this one, but we're going to give it a try live and see if it works. So I just actually got a Spring AI MCP server with authentication working, and I'm going to see if it actually works. This will be fun. Okay,
can we zoom in a little just to see
yes.
My old eyes are.
Thank you. Let's see. Is that any better?
Cool. Yeah.
Okay. Okay. So, so I created an MCP server for my book that I wrote with Bruce and Bill, and it's so that you can get the book through an MCP server. And so I'm going to try to see if it works because this will show kind of the auth workflow. Okay. So the URL for the book's MCP server is https mcp.effect-orientedprogramming.com/mcp. Okay, so if this all works as I hope, when it tries to connect to that MCP server, what it should do is say that you need to authenticate, and then it should walk me through an OAuth flow to be able to connect to that MCP server. So still connecting, come on. So this is the fun thing about doing demos you didn't prepare for, is who knows if it's actually gonna, oh no, streamable HTTP post. Oh shoot, well I broke something. Try it one more time. Dang it. Demo failure. Okay, well I need to see what I broke on my MCP server. But this is
definitely MCP dot effect oriented programming /MCP, because you do have a,
yeah, should be. Yeah, I think that's all right. I don't know. I probably broke something on my MCP server. We'll just go see real quick what make sure I got the URL correct there. Yeah. Oh, and I'm running this one on Heroku. But I need to, yeah, I don't know. I screwed up something with my latest deploy or something. Who knows? Okay. Anyways, what should have happened was that Curo will actually say like, hey, you need to authenticate to the server, and then it does the whole OAuth three-legged, OAuth flow to allow me to then log into my, because I don't want just everyone to get the book for free, right? Yeah. So it allows people to log in, and then once they're logged in, then they have access to the MCP server. Okay, cool. And that's all built on Spring AI. So yeah, I'll get that working right after we get off the live stream. Okay, so let's talk about AgentCore now. So AgentCore is a AWS service that can host MCP servers and agents, AI agents. And so with if you want to host the MCP server we just built, if you want to host that on an AgentCore, all you have to do is turn it into a container and then deploy it up on AgentCore, and then you've got this like serverless hosted environment that manages all sorts of stuff for you around your MCP servers. And then on the auth side, you can either use an OAuth like JOT token provider like Cognito or others, or you can use IAM for the auth as well. And then, so you've got the MCP server hosting. You can also host agents. And so what I want to show is another Spring AI agent that we're going to run on AgentCore. So was that a good description of AgentCore, Julian?
Yeah, that's yeah. An agent calls a whole lot of different pluggable things. So there's observability, and there's a web scraper, and there's authentication memory, memory, all the kind of things. So they're all built to build together, but you don't have to use them separately. And they're also model agnostic and framework agnostic. So you can pick and choose the best one for your job.
Yeah. So we've been working on adding AgentCore support to Spring AI, and this is currently in development, but I want to show you what this actually looks like. So I'm going to switch over to another project here, which let's cancel that one. This is another project. In this case, I'm using the Converse API, and I'm connecting to the Nova Light model. But again, totally whatever you want to use for your model. And then the code here should look pretty similar to what you saw before. The one major difference is that from that library, the Spring AI AgentCore library, I now get this annotation, which is AgentCore invocation. And what that's going to do is just like set up everything that's needed for this agent to be able to run on AgentCore and handle requests. And then there's AgentCore has a way to know if the agent is busy, if it's able to respond to requests, and so this annotation sets up everything that's needed for that for us. So in my case, what I'm doing is taking a prompt in, which is going to have a question field, and I'm just passing that directly on to the LLM and then returning the response. So pretty basic agent here. One of the nice things is that I can spin up this agent locally, and this is just, you know, Spring AI. I've given it my AWS credentials, and so in this case, you know, I could configure the Barrow token, but I think for this one, I'm just doing the kind of old school way of AWS credentials. So great, this thing is up and running. I can run a test, so I have a way to send an HTTP request to this thing and hit run. And when I hit run, great, we got a joke, always the same joke. Why did the Scarecrow win an award? Because he was outstanding in his field. That's the Nova Light, like, always responds with that same joke. It's kind of funny. Okay, so that's my agent running locally, but let's get this thing running up on AgentCore. In this case, I used CDK to be able to push my code up and do a code build on it and create a container. But ultimately, what I need is to get to a container image. It does need to be an ARM64 container image, and so there's, you know, you got to figure out how to do that. That's part of the reason why I was using code build here is when I'm on my usual Linux machine, that's an Intel machine, I can't just create the container locally. But anyways, I use CDK to do all that. Then I've got my container. I've got my container up and running up in ECR. And so let's go here. So there's my container image that's up on ECR. So 135 megs, not too bad for that image size with the JVM and the Spring application and all that kind of stuff. I should try to do a native image version of this one. Okay, so I got my container image. Now over in AgentCore, let's go host an agent, and I'm going to say use an ECR container, and then I'm going to browse the images, and then I'm going to select, it's this one, and then, yep, that container image, and select. And obviously you could do all this through IAC as well, but I just wanted to show it through the console how to do it. And then we have to give it the IAM permissions, and then we can select the inbound auth. So for inbound auth, I'm going to use HTTP, but if you're doing an MCP server, then you do MCP, which has its, you know, way of doing auth, or A to A for agent to agent stuff. And then you can specify if you want to use IAM or JOT token. So that's it. And then I don't think I can do it in a VPC, set environment variables. Let's hit host agent. And if I did everything correct, once this hosted agent MJQXN is provisioned, then I'll be able to test this thing out. So, okay, so great. So my agent is up and running. I've got an endpoint there for version 1. So there's the ability to like spin up new versions and have the router, you know, decide how to route to the different versions and all that kind of stuff. So all that stuff's just built into AgentCore. But let's go over to Agent Sandbox, and then I'm going to select the, come up in the list. That's not the, let's see. Oh, still creating. That's why. Okay, once it's done creating, we'll be
so just question about the CDK creation. Yeah. Was that the CDK to then create the ECR repository, create the Docker file, and upload that? Ultimately, your Docker file wouldn't be that complicated, and you could just, you know, post that up to ECR using, you know, Docker CLI or Finch or something like that.
You certainly could. Yeah, okay. You certainly could do it that way. I was initially going to show it going that way, but I couldn't get my Docker desktop like authenticated. So I gave up and on this machine on that approach, and then I switched over to my CDK, and I wrote all this like wacko crazy CDK stuff to be able to push my code up, and then build the code into a container image on using code build. And
yes,
I'd like there's all sorts of stuff, and then I can in here as well actually do the deployment to AgentCore, but this particular one I just got the container image built up there. Okay. Okay, so we've got our, it looks like it's all ready now. Let's go try that again with Agent Sandbox. And this is that hosted agent. I can specify the endpoint, and then I need to give it some JSON, which easiest way to do that is just copy and paste that one. And so now let's paste in our JSON here and hit run. And so this works in the console because of IAM. The IAM credentials just get passed automatically for me. But yeah, there we go. We got our output out of our agent. So all running on AgentCore.
And then that AgentCore agent is going to also charges you and only runs when it actually has requests that come in. So in a way, it's similar to Lambda, that it's request-based usage, but it's got some benefits that it can also be super long running. So it isn't just for Lambda's 15 minutes. So if you do have a long running agent application, that's absolutely fine. And behind the scenes, it's also using similar to Lambda's isolation technology. So it is also super secure.
Yeah, it's like Firecracker underneath the covers. Is that right? And then it does, I think it does some isolation, some like session isolation as well. So I think that like given a particular like session ID of a given user, I think that it'll keep that instance like warm for some amount of time, and then route all the requests from that user back to the same warm instance. And so definitely does some like isolation that's per user. That's interesting and a little different from how Lambda does things.
So you're using the web playground for IAM. If you were then to connect it to either your local or another deployed web app, what would that config look like?
Yeah, so there is a way, and I think that's the typical way that you would do that. So let's say I then had a Lambda, and I wanted to invoke the agent from that Lambda. The easiest way to do that is to use the AWS SDK, and there's like a invoke agent kind of call within the AWS SDK that will then make that call to the agent. And then if you're running on Lambda, then you can pass the IAM credentials through as well. And then I have a more complete sample that has the agent and then the MCP server, and those are connected and authenticated. So when the agent calls the MCP server, it's authenticated calls to that MCP server as well. So that's the example that I showed with the add MCP server and the agent. You can run both of those things on AgentCore and connect those securely, and you can put them in a VPC and all sorts of good stuff.
Do that kind of stuff. Yeah, and I suppose if you just want to say have a front end application, call your agent directly, you could then put a gateway. Well, you could put an API in front of that agent, and part of AgentCore is a gateway, and so or a runtime and an I'm blabbing away. So there is a gateway you can put in front of it. So I'm not quite. That's just for MCP, or also for just running a general API in front of your agent. But you can also connect API gateway. There's a seamless connection. To be able to run that publicly, run your agent publicly but securely.
Yeah, and I've not done that, but it all seems possible. So, and Gateway, there's a bunch of different parts of what Gateway does. Part of it is being able to create a proxy to a bunch of MCP servers, and then it can do like semantic tool search, and there's all sorts of additional features.
Yeah, because that's actually quite cool. If you do. If you want a gateway to your existing tools, but you don't want to MCP-ify them, that's a great term. So you can just have your existing internal APIs and create a gateway in front of them which are MCP compatible without having to mess around with any of your APIs, which then becomes tools. Name them. And the other semantic search is actually really cool, because if you've got hundreds of tools, maybe you don't want to be filling your LLM context with all of those tools, and so the gateway can.
And it gets harder for the LLM to reason about which tool to call when you have a bunch. Yeah, and Gateway can be a gateway to a Lambda function, so you can just take a Lambda function, expose it as an MCP tool, and super straightforward. Yeah.
Cool, excellent. Well, James, can't believe an hour's gone, or 58 minutes has gone ridiculously quickly. In the last minute, what other things would be useful for people to take away from? On YouTube, the link is AW Events channel. There are loads of links which we put in there. So we've been talking Spring AI and all other kind of things. So that is already there.
Yeah, no, I think there's tons of resources out there about how to do Spring AI and how to do it with Bedrock. I've got a bunch of videos and yeah, great documentation on how to do all these things. And yeah, keep an eye out for that Spring AI AgentCore stuff that we're working on. So yeah, fun times in the world of Java and AI, and Spring AI is a great option. Also mentioned in Babel, like check that out if you're interested in some things that go beyond the kind of, I don't know, in a way like AI primitives of Spring AI into like more of an agent framework style. And so, yeah, of course, Babel supports Bedrock as well. So yeah, just fun times in the world of Java and AI. So
well, thank you very much. I'm just holding up my screen here. I looked up, I've got Thinking in Java, bought in 21st of September 2001 with CD-ROM. So that was from my Amazon shopping cart. So yeah, I had the book ages and I sadly didn't do enough of it. But James, thanks so much for joining us. What a pleasure. We'll be back same time, same place with more Serverless Office Hours. So thank you, James. Goodbye.
Thank you. Thanks for having me.